when it's doing optimizations, it's going to say, wait a minute, we don't need that, we don't need that. So when you're trying to detect no-ops, when you're doing static analysis, it's very easy to find these things. So it's not particularly an effective mutation. And also huge unchecked growth, right? You put something into the code that's not going to do anything, and oh, by the way, you're going to mutate it into more stuff that doesn't do anything.
And for worms, that's something that's kind of hard to check yourself, because as it grows and as it throws in more and more stuff that's not going to be used or that's just going to blow it up into more garbage, that's stuff that you would have to have pretty much like an optimizer built into a compiler that sits inside of your worm. Again,
with the worm, we tried to implement as simply as possible without having to actually tug along a full JavaScript tokenizer and parser. We wrote one recently. We actually did a demo in our talk yesterday about analyzing obfuscated JavaScript and things like that. And for that, we wrote a full one in C#. But it's not really practical to try to pull that along. So this is the fun thing, right? Updating the attack vectors in the wild. We're going to release the worm, and it's going to have maybe 3 SQL injections and a cross-site scripting attack that it knows about.
He's speaking hypothetically. We're not actually going to release the worm.
No. No. That would be bad. I wonder how many banks there are in China that are SQL injectable.
It'd make an interesting weekend.
It would. So this prevents the silver bullet fix, right? Because if we start it with 3 vulnerabilities, you can go ahead and eventually, as soon as somebody gets a copy of the word, they're going to say, wow, you patched these 3 vulns and the worm's not going to propagate anymore. It's, the whole SQL slammer. Granted, there might be variants that people kick out later, but if you patch the box, it's not going to get exploited. So to be really evil, you got to update how you exploit them while the worm's in the wild instead of trying to release variants all the time. Also, the FBI can track you down a lot faster if you keep pumping these things out from your IP, different variants. So what we're going to do, there are 2 ways you can actually update these methods. You can actually fetch and parse new known vulnerabilities from security websites while it's in the wild, or you can actually discover vulnerabilities on the fly. Now, only certain vulns are interesting.
Both, don't we?
Yeah, we'll get to, we'll go past the next slide. So only certain vulns are interesting, right? Because we're looking at things like cross-site scripting, command execution, SQL injection, file upload.
But it's got to be stored cross-site scripting and like for the SQL injection, it's got to be reflected back. I mean, there's certain things that a normal cross-site scripting attack might not be good because you can't really hit people like without directing it toward them.
But these attacks,
you've got to fish them to kind of pull it off.
But these attacks are good. I mean, as I'm sure Arsnake knows, he goes ahead and pounds away on trying to actually get cross-site scripting to exploit or something like that with various attack vectors. It doesn't crash the box, right? I can sit there pounding on MySpace all day with trying to get around their filters, and sometimes do. But I can do that. I'm not going to crash the box. I'm going to generate some network traffic, but it's not like I did a buffer overflow and I messed up and I cored the process. So it's really good. These types of vulns are very good because once the worm is aware of, there's a cross-site scripting vulnerability in this version of this product, it affects this parameter, and it's on this, say, this file or this page. Maybe it doesn't know the exact attack string it needs to do, but it can go ahead and put kind of like a preamble on the front of its attack that it'll know maybe will break it out of a comment or break it out of attributes. So the worm can kind of figure out how to get around the filters. It just needs to know where to actually inject. So like we said, buffer overflows, format string vulnerabilities, they're not really going to help us here. But they could if you switch over to something like a Metasploit exploit. Where that's true. Because this is a scripted language and Metasploit is Perl, you can get the one exploit that you need, and you can run that. So if you pull something that's not a browser, you can probably run that and continue an infection that's no longer web-based. Exactly. And this is where it goes into more of like a hybrid sense, that it's not just scripted languages. Now a scripted worm can also start to control boxes that were infected via like a buffer overflow or a heap overflow. There's so much that can be done if you're going back and forth, and it can keep moving, and it can get past things that weren't designed to have web access, and all of a sudden you kind of bridge that gap. Right. Like, for example, if there's a command execution vulnerability, or there's, say, a SQL injection vulnerability, and I can access a stored procedure that lets me run commands, I can run a command to pull Metasploit down, and then run Metasploit on the server. And so I can, instead of trying to find buffer overflows and then try to, get everything all working, I just use a pre-made exploit. And I've got all of Metasploit, which will give me all sorts of exploits. So this is where security vendors hurt us, because they like to talk about how cool and sexy they are. They want, and Hey, I work for a security vendor and we do this too. We'll go ahead and post, hey, there's this vulnerability, it's this criticality, here's the affected version, there's a patch available, and here's maybe some little more information about it. But the thing is, the security vendor vets the vulnerability for you. He tells you, Secunia is not going to publish something that isn't really vulnerable. So it's not like I'm having to read full disclosure, right? It's not like the worm has to read full disclosure and try to parse out some 13-year-old in Brazil going, I have elite skills and bad English, and describing how he's doing a command injection vuln, right? Secunia takes the 13-year-old Brazilian who can't speak good English and puts it into a nice, well-formed document that I can understand.
Can't speak English well.
Oh, I'm sorry. So they basically vet the real vulns out for me. And then they produce vulnerability reports in a very known format. They tell me the type of vuln, the product, affected versions, is there a patch, what's exploitable. Sometimes they actually give me the attack string, but even if they don't get me an attack string, we can figure it out. They tell me if it's patch available. Even better, they put this information in RSS, which is machine consumable. So in some cases, I'm having to screen scrape, but sometimes they're just like, hi, here's an RSS block of what that vulnerability is. Just consume this, and now you know how to attack, PHPBB, or now you know how to attack, shopping cart XYZ. And it auto-updates, which is nice. So you can discover vulnerabilities on the fly by pulling down, say, a scanner. If you're running on the server, you could grab a web vuln scanner like Nikto. If you're running on the client, you could grab a web vuln scanner like Jikto. Which certainly needs to be fleshed out, but all you really care about, you don't care about known checks or fixed checks. You don't care that there's a directory called admin that we can access, because that's not going to help you. You're looking for things like cross-site scripting, SQL injection attacks. You're looking for kind of like, you don't have the attack string, but you want to try to exploit it. So it generates lots of traffic, but scanners are very helpful for when it's a custom app, right? No one's publishing that there's this vulnerability in your application. Also, I could have a website and I've got robots.txt, so that maybe I do have PHPBB, but I have robot.txt up there, so Google never indexed it. Google doesn't know. If I do a Google dork looking for vulnerable versions, I would never find you. But if the worm is running in your subnet or inside your intranet and go ahead and does a web scan, I can now find you. So how do we find infected hosts? Well, search engines, of course. Like I said, unless we're actually running and doing sweeps of your intranet. On the server, this is easy, right? I have code execution, so I can go ahead and either talk directly to Google through Perl LWP. You could do it on the command line with curl or wget. This isn't complicated. On the client, it's a little harder to do cross-domain communication in JavaScript because you're not supposed to be able to do it, but you can. It has to deal with web proxies, and I don't really have enough time to go into this, but this is a pretty well-known thing that kind of got discovered by PDP last year, and he's talked quite a bit about it. I've talked quite a bit about it. Google actually also has something called the Google search, the Ajax API search, where you can actually, in JavaScript, basically tell Google, hey, Google, search for this, and when you're done, call this function and give me the results. So I can actually query Google without having to do any crazy hoops. So we basically use Google to find hosts.
But for client side also, that works for port scanning and for different kinds of fingerprinting, where you can go after like the inside of a network, and you can start going through the 10 range, the 192, and you can start finding stuff that you would normally need a server for.
Exactly. So now that we know how we can contact a search engine to find these new vulns, because think about the progression here. We're mutating the code so you can't signature it. It's going to have certain vulnerabilities it's exploiting, but we have found ways to contact, say, Secunia or these other people and actually extract the information. Oh, I didn't show that. So this isn't actually hooked up for where it will actually contact Secunia through a cross-domain way, but we've already kind of showed that in previous conferences with Jikto and some of these other worms that are out there. So I'll just go ahead and I heart Secunia. So this is a Secunia advisory. And so, I grab the HTML. This is like the setting the stage, doodle-doot, just trust me, hand waving, this is what happened. Somehow you grab the HTML, which you can do through a cross-domain request, going through a web proxy, using Google Translate in ways they never intended. And at this point, this isn't all, not that. This isn't even all that super sexy, right? It's just regexes. But Secunia has very regular reports. They're 3 paragraphs or 4 paragraphs. The first paragraph is literally the format, blank has found a vulnerability in blank version blank. Next paragraph. The affected parameters are blank, blank, and blank, and the page is blank. And so we just use very simple regexes to extract all this information out. Let me go ahead and copy this. And that's when we have to do screen scraping. That's assuming they didn't just give it to me in a RSS feed that's already consumable. So we just throw that in there, and we see that the product is Form Processor Pro. It's version 4.0. Form Processor Pro.php and Form Processor Pro.pl are vulnerable. This is cross-site scripting. It didn't pop up. And the parameter that you want to attack is base path. In which case, I take this information, I immediately go to Google, and I say, hey, find me things that say powered by, Form Processor Pro version 4.0. Let me scrape all of those. Let me find and in URL is base path or what have you. Find it and exploit it. So going back to here. So we've mutated the source code so they can't stop us. We update the vulnerabilities on the fly. The trick is we want to make sure that they can't stop us from searching Google and finding targets. I mean, that's how Santi got stopped.
Right.
So what we want to do is, the fact that we're searching for multiple vulnerabilities is going to kind of help. But Google could always say, hey, we know this worm's in the wild. We know it just was able to pull down this new exploit. We know there are versions of it that are now exploiting this. If we ever see someone doing a search for powered by, what was that, Form Processor Pro, just give them an error and, give them maybe a Turing test before they get their results back. So what we do is we mutate the search string. We go ahead and say, well, you normally use modifiers like all in URL or in URL. If anybody here does a lot of Google hacking, well, we can use those interchangeably. We can add words that we know Google's going to ignore, so that the query looks different, but actually it returns the same results. I can, like for example, Google only returns the first 1,000 pages. So I could do a search for, powered by XYZ123 and powered by XYZ123, copyright 2007. That's probably going to get me back almost the exact same result set, even though the search string is entirely different.
But we're not positive because it's kind of magic at the end of the day for what it strips and what it doesn't.
Yeah, I'm not sure where Google applies this. I'm not sure how much they normalize the query before they say, wait a minute, is this a bad query or not? So.
Yeah, because if it goes for the sting, you might get a good movie or you get the best part of the police. So it could go either way. It's going to strip out or it might not, and it's kind of case specific.
Right. So payloads of the worm are certainly interesting. I mean, it's really at this point whatever you want. If you're exploiting the web server, and we're on the server component of the hybrid, I'm running with the privileges of the web server. So I can bootstrap local exploits. I can do privilege escalation attacks.
You can write back out the files.
Pull out Metasploit.
Right.
Whatever you want to do. If you're on the client, you can do all this crazy JavaScript stuff that we've seen over the last year or two. Stealing your search history, port scanning, fingerprinting, cross-site request forging into intranet applications.
But that's really loud, so it's kind of like a crazy drunk guy going through the halls of a church. You know he's there.
Right. Certainly, stealing history and stuff. Luckily, it's all DOM manipulations, but certainly port scanning, fingerprinting. If I'm doing cross-site request forgings or like the MHTML hack, things like this, these are they're very distinctive requests. Jicto's extremely loud. And so another fun thing you could do is use dominatrix, which is what we wrote.
Those are actually my legs.
Well, I was sitting around at TourCon, and Dan Kaminsky and I were still a little hungover, and he said, you know what, somebody should make a cool called dominatrix. And I'm like, yeah, the DOM, it abuses the DOM, and the DOM likes it. And so he's like, well, we got the name, we got to think of what a tool could actually be that does this. And so I'm like, okay, well, we could make it a SQL injector, because, I mean, we've seen